Okay, what we have here today is a 2009 Ford Everest with a 2.5 common rail diesel engine. The owner purchased it from an auction. The engine wasn't running. I think it was running, but it would crank, start, but run very poorly and would stall. So it was towed here. Ivan took the 4 common rail injectors off, diesel injectors off, and took them to specialists. They were cleaned up, brought back on the vehicle. The vehicle now runs and actually idles in a stable manner. It cranks fine and idles fine. And but the customer complained it felt like it was sluggish, it didn't have power. So Ivan came, looked at the timing, found it was off a bit, redid the timing and ran again, and the engine is running again. It hasn't been test driven yet, and I walked in this morning and was asked to have a look. So that's where we are at right now. Engine runs, timing has been done, road test not yet done. Just double checking that there is nothing electronic wrong with it. So that's the engine. We shall go into the vehicle now. It's a 2009 Ford Everest with a common rail 2.5 liter diesel engine. Okay, I'll crank the engine first so you hear it running. Yeah, it's running. Check engine light goes out. Check engine light goes out, but not the ABS light. I'll check that out too. So we come to the diagnostic computer. I've already set it up for. I've already set up the software for the vehicle. Okay, I'm now in. First checking that there are no fault codes on the engine control module, and indeed there are none. Out of interest, I'm just going to check. I'm first checking why the ABS light is on, so I'll go back and have a look at that. ABS will be under brake. Okay, we have a C1096, that's ABS hydraulic pump motor open circuit. So I'll have Ivan check that out. I think that's not a very difficult case to diagnose. It's just two, I think it's just two wires that feed the hydraulic pump motor. It's very easy to check out its open circuit. I mean, this vehicle has been sitting for a long time in some yard where it was auctioned off, so maybe there is a socket off or something, or the motor itself is bad, whatever. Okay, I'll go back to the engine issues, which is where my main interest is today. Once again, no fault codes. After that, I want to go into real-time data, and actually before that, because the engine is idling properly, I don't need to go into the data to have a look at, because I wanted to go into the data to look at the fuel pressure, but this engine is idling normally, and even when you step on the accelerator pedal. Yeah, engine runs okay, so sounds okay. So I think the fuel pressure is okay. I'm not really going to go into at this moment. I want to check that all the injectors are contributing kind of equally. So I'll ignore the real-time data for now and go into the engine testing software. Oh, my battery is running low. I want to test the injectors first. Injector number 1 contribution. I'm testing it. Yeah, I don't know if you can hear the vibrations. Yeah, but it kind of misfired a little when I shut down that injector number 1, which tells me that injector is contributing. I'm doing the same thing for number 2. A bit of misfire, so that injector is contributing. Number 3, engine misfiring. I don't know if you can see the shaking of the cable here, that cable when I do that. So that injector is also contributing. And then we go to the last injector, which is injector number 4. I don't know if you can see the shaking of the cable. So that's a bit of a misfire when I shut down that injector temporarily. So that means all the injectors are contributing equally. I'm also going to tell it to do a self-test with the engine running. So the ECM is going to do a self-test, and I have commanded it. You may feel oh no, just about to command it. Okay, the self-test has started, and you can see the engine vibrating. I think it's testing the injectors and other components. It's misfiring a bit, so it's checking various things. Still misfiring. Okay, it has finished the test. The engine is running okay now and says it hasn't found any faults. Okay. No, I'm not going to erase any codes because there are none anyway. So I want to go into real-time data again, the custom list, and my main interest is in seeing what the data for the programmed IDs for the injectors, plus well, maybe I can throw in the okay, that's what I want to see for now. And okay, that's the programmed injector information. Those numbers, you normally find them on the injectors themselves. They are normally printed. They tell the injector, the engine control module, the characteristics of the injectors. So it is the engine control module deals with the injectors using it knows its characteristics, and it handles each injector separate from the other. So I need to be sure that what I'm reading here, that in that order those numbers are matching on the engine. In other words, the injectors are in the correct position according to how they were programmed in the correct positions on the engine according to how they were programmed on the computer. Before I go back to the engine bay, I was thinking maybe I could I could check the fuel rail data too. fuel rail pressure, where is that? Okay, there. Throw that into, have a look at that, 34 MPa. If I try to rev the engine up, I want to see that going up, and it is. I want to see it in graph mode. Right, so the graph is there. Let's see it going up. Okay, now that what that tells me is at least the fuel pump can keep up the commanded rail pressure. So final thing, my laptop is, the battery is warning, it could go out any moment, but final thing I want to do is go and check that there are no fault codes, and I don't have any, so I don't think I have fuel rail pressure issues on this case. I'm now going to the engine bay. I'm going to make note of the of the numbers on the injectors in their sequence, and then compare them to how they are programmed in the vehicle. My laptop battery has actually kind of died on me, has it? Yeah, I think so. It's shutting down. So I'm moving to the injector. I'm going to check the injectors directly on the engine, and I've already made notes of those injector of the injector codes. So I'm going to compare them against what's actually on the engine. In what order are they on the engine, or are they even the same numbers that we saw being programmed into the ECM? Are they the same, or are they even in the same order if they are? Yes, so while the laptop is charging up, the laptop, I went round to the engine bay. These are the injector codes that were programmed in the computer, and I discovered that the injectors haven't actually been changed since then. Were just cleaned up. I discovered that the injector with this code, which is supposed to be for number 1, is sitting in the cylinder number 3 location. So that's wrong. This injector needs to be moved to inject to cylinder number 3. Injector number 2 is sitting in the right position according to the ECM programming. Injector number 3 is sitting in cylinder number 1, so this needs to move to number 1 cylinder, and then injector number 4 is also sitting in the correct position. So injector number 1 and 3 have to be swapped around. Okay, we now want to rule out very quickly any mechanical issues, obvious mechanical issues, using the diagnostic tool, because the laptop is still charging at the moment, but using this another diagnostic tool, I wanted to compare the desired RPM, to the actual RPM. The desired RPM at idle is 720, and if we scroll down and look at the actual RPM, is hanging around there, as you can see highlighted there. So it's drifting around a bit, but that's fine. So the ECM is in good control of the RPM, which is a good symptom, at least with regards to injector control. And also very quickly, to rule out turbo boost issues, I needed to compare the barometric pressure signal, that is the signal and that is the interpretation. On top highlighted is the interpretation of the ECM of the signal with regards to barometric pressure, and I can confirm with where we live that the correct number you should be seeing 88 kPa. And then compare that against the map sensor reading. At idle, without any boost or with very little boost, the map signal or the map reading should read very similar to barometric pressure. But once you speed the engine up and the turbo does any boost, you should see the map. Sorry, I got interrupted by a phone call, but looking at the comparing the barometric pressure reading versus the maps sensor reading, once we rev the engine up like I am now, we expect the map sensor reading to go up, and it is, as you can see, it's going up to, I think I've seen a peak of even 180 MPa. So to me that is a turbo that's responding, that's creating pressure. The actual voltage signal from that sensor is right there, and we can watch it too. See that it goes up and down as I rev and release the gas pedal. I think I'm happy with both the map sensor and what it is telling me. And finally, I wanted to see something about this EGR valve. Apparently it's on all the time. Oh, the turbo, the duty cycle commands for the turbo valve. There is a solenoid valve that controls the position of the vanes in the turbo. I need to see it switching downwards from those higher figures, lower figures as I rev up, and it's doing that. So the solenoid is doing its, the computer is doing its job with regards to controlling the turbo through the solenoid. It's sending the right command, and the solenoid is responding, the turbo is responding, and I get the correct what I think are the correct map sensor reading. So I think I will move away from the turbo issues. And then the EGR looks like it's always on with the engine at idle. I don't think I can force it to be turned off. I can force the ECM to turn it on, because I think it will normally do that when you're driving, and right now I'm parked in the garage, the vehicle is stationary, but I'm assuming for now that the EGR valve works like it should. At least I think with diesels the strategy is normally the EGR is open at idle or lower engine speeds, and at cruising speeds I think that's when it's shut off. I think the computer was also giving me data for EGR valve control. Oh, I've have to reset my data list again, but we had seen most of what I wanted to show you. What do I want to show you now? Maybe EGR, desired EGR gas, EGR valve position, which is that. I think the duty cycle for that is normally low with the valve open, and once the ECM needs to close that valve, it will increase the duty cycle for that. I can't seem to be able to force it to command the EGR to close, but I will ignore it for now, because earlier I did a self-test, an engine running self-test, and it returned no fault. So at this point I will assume the EGR is working like it should be. That we've ruled out turbo issues for now. Yeah, I think that's about it. If this vehicle doesn't improve, maybe there is another mechanical issue that I can't pick out. Maybe I should disable fuel and then crank the engine and look at the relative compression of the 4 cylinders, just to compare the 4 cylinders against each other with regards to compression. I think that should be the last step we take with this one.